Okay, everyone. Today we are going to be looking at functions. Yeah, functions. Functions is applicable to all languages, whichever language that you are doing. But the method and ways in which they are being implemented are varies, but is the same concept across all languages. Now, what are functions? Simply put, functions are used to envelop your code or package them for reusability. By reusability, I mean you don't have to rewrite something that you have written yesterday or 3 years ago or 4 years ago or last 6 months or 2 months ago. You don't have to rewrite it. So all you have to do is call the name of the function, and every function has a name. Yes, every function has a name. Let's say, for example, now I want to write a program now, just a program to add two numbers, to find the sum of two numbers. Now I'll do something like see, let's say I have n as n, let's say n1 as 2, n2 as 7. If I have to add these two numbers, I'll do something like result is equal to n1 plus n2. Then I'll go ahead to say print results. Let's run our code to see what happens. Okay, I got 9, yeah, which is correct. Now, if I have to write this code tomorrow, probably in another file, or maybe somewhere in this same particular code, let's say maybe this particular code file now is about 100 lines or 200 lines, and I have to repeat this same concept now in terms of adding two numbers. I will have to repeat it again. I have to write it somewhere else again. Let's say I have two numbers now. Let's say I have another two numbers, like let's say I equal to 19 and j is equal to 7, and I want to write a program to add 19 and 7 again. I'll have to do the same thing again. Result equal to I plus j, and I'll say print result, and let me run my code, and it will give me 26. Yeah, so I'll keep on doing one thing over and over and over and over again. It doesn't really make any sense now, right? So it is better for us to just write some kind of like a blueprint to add numbers, so that whenever we want to make use of it, we can just call that particular function. We can call it. All we have to do is to replace the certain things called parameters now. Yeah, certain things that are called parameters to a particular function. Yeah, when we replace it, then it's kind of like collect the values of those parameters and use it to perform whatever logical calculation it has to perform within the body of the function. Now, in Python, how do we define a function? This is how to define a function now, using the Python keyword called diff. Using the same example we did just now, adding two numbers now. Let's write a function now to find the sum of two numbers. Diff and say add two numbers. The number will be num1 comma num2. Whenever you're defining a function in Python, you have to start with this keyword here, def, followed by the function name. Now, naming a function follows the rules of variable naming. It's the same convention. You don't start with a number, and it's either you use the camel convention or whatever convention you feel it's comfortable for you. I can just write something like add underscore 2. It means that I'm adding two numbers. It's a good function, but I cannot come here to write 5 now or something. It doesn't really make sense. I can do something like, let's say, add 2. Yes, it's correct, but sometimes I really don't fancy the idea of using numbers within a function name, so you just write add 2, and that's it. Then I'll hit my enter key. Then right now, where this particular cursor is located is the body of the function. We are within the body of the function. It is here you write a whole lot of real estate code to perform whatever calculations that you want to perform based on your logical thinking, so that whenever you call this function tomorrow, it will perform these particular logical calculations for you to get the results. We're gonna go ahead to add these two functions. I'll say result equal to what? Num1 plus num2. Then I'll come here to say return results. Now, this is a return statement. Return statement helps us to return the value of the final result and the final answer of our logical calculation that we have done within the body of the function. Now, it is not a must that you must use return statement. As a matter of fact, there are two categories of function. We have fruitful function and fruitless function. Fruitful functions are functions that return values, while fruitless functions are functions that doesn't return values. Now, if I don't want to return any value from this function now, I don't have to write this return statement here. I have to remove it. But because of the fact that I need to view the results of my calculation, I need to view the results of the summation of these two numbers. That is why I'm using a return statement. Now, the result I'm using here, it's not compulsory that it must be result. You can use whatever thing that you want to use. You can go ahead to say ROES, and I'll go ahead to say ROES. Yes. So long as what you are returning is where you have actually stored the answer of whatever calculations or whatever thing that you have done within the function. So I will now go ahead to do something like, now I'm outside the body of the function now. Now remember I talked about Python and indentation. Yeah, it is very compulsory that you know that Python works with indentation. If your code is not well indented, you will not get the right result. In fact, it's a syntax error in Python. The reason being that over the years, C and C++ and Java programmers, they've written codes that the language does not really care about the spaces you leave or the indentation and all that. And so many code has been so much confiscated and difficult for programmers to read. So the creators of Python decided to make it compulsory for you to follow a particular indentation pattern so that your code will be well indented for other programmers to read. So when I hit my enter key, I went outside this particular line. This line and this line, they are on the same this statement and this statement, they're on the same line, but outside it now, I am already outside the body of the function. So whatever thing I write here will not affect the results or whatever logical operations I have performed within the body of the function. Now, what I've just done here is called function definition. I've just defined the function. I've just created a blueprint of the logical expressions now, or whatever calculations or whatever operations that I want the function to do for me. I've just created a blueprint of it. Now, how do I make use of it now? I will have to call the function. You can either call the function from within the body of the same file that you have defined it, or within another file. Yeah, whichever one you want to use. So we're going to be calling this particular function now. But before we call the function, we need to pass values to this function, because what you are saying here, if I have to call this function and I do something like add to, it won't be correct because it does not satisfy the conditions of this particular function definition. It does not satisfy the function signature. The signature of the function demands that I pass two values into this place so that it can perform whatever thing that it wants to perform within the body of the function. So if I come here now to say add 2, I write 6 here, comma, I write 7 here. I will now go ahead. If I go ahead to run this code, yes, it will run well. Let me go ahead to run the code, but I don't think we're going to see anything because we are not using the print statements to print out anything. Let me hit the run button, and program finished with exit code 0 means everything ran well. And there's nothing, yeah, but at least the code ran well, no errors and all that. So I'm going to come here to say print. Okay, let's do it this way. Let me create a variable here to say I can put results here is equal to add two numbers. Now, the reason why I'm using a variable here is because of the fact that I'm using a return statement here. If I hadn't put a return statement here, there wouldn't have been any point using a variable here. to store, because this return statement is actually returning the result of the addition of this or of these two numbers. So when it returns it needs a particular variable to catch the result. So this result here now is catching it. Now, like I said, it's not almost that it must be result. It can be anything. I can go ahead to say, I can write Z here now, whichever one. Z is a variable. So Z will help me to store whatever results that I am returning from this particular function. So I will now go ahead now to say print Z. And when I use print Z, when I hit my run button, we're going to get the result. Yeah, the result is 13. Right. Now, the argument I passed into this particular function now, they are constants, as in they are literal constants. You can pass variables into this function. The example we gave just now, when we added our n1 and n2, x and y and all that, let's recreate it now. Let's say n1 is equal to say 7, n2 is equal to 6. Then we have our x is equal to 8 and our y is equal to 9. Right? Okay. Now, I want to use this particular function now to perform a calculation that will add these two numbers together. I'll go ahead to say I have to put the values. If I want to add n1 and n2, I have to put n1 here. Then I'll go ahead to put n2 right there. Then when I run my code now, let's see what will be. Yeah, our result is 13. So that if I come here now to put my x and my y, I will go ahead to run the code. And let's see what it produces. It produces 17. Yeah, it shows that our program is running well. You can see that you can continually using this add to function anywhere in your code. Anywhere you need it, you can add two numbers. Anywhere you need it, you can add two numbers. You don't have to rewrite certain things. You don't have to write certain things. Again, you don't have to write whatever operation that you're going to be writing within the body of the function. Then another concept that is extremely important to understand about functions is this: what you are passing to these functions as arguments, they are copies of the original values. You are not passing the real value here. Now let us write a function now to multiply a number by 2, and let's see if we can change the value of a number using the function now. If I write a function now here to say let's say I say df change, and I write say okay, then I'll go ahead to say change. I'll say I is equal to I times 5, then return I. So I am doing something like I am taking this I as an argument, then I am actually multiplying it by 5. I am storing it inside this same I. I'm multiplying the value of this I by 5, and I'm storing it inside this same I. So I will now go ahead to do something like change I, right? Okay, let's assume I have something like this now. Okay, now change I. Okay, I have to return I now. I have to return I. Okay, return I. Then I've already returned it. Okay, I thought I haven't. Okay, so I think I'm on the right track. So let me go ahead now to use this particular function now. I'll say let me use n as an example now. Let me change my n1 to, let's say, something like that, meaning that if I have to change my n1, I'll be multiplying n1 by 5 now within the body of the function. So I will say change n1, right? Okay, then I'm going to store it inside this variable called result. Then I'll go ahead to say print result. Then I'll go ahead to say print n1. So let's see what goes. Let me run this code now to see what happens. So I have 7. Okay, I have 35. I have 7. Oh, it's executing this same code here. Let me comment out this code so that we are clear about things here. I'm printing out these results and this N1 now. Okay, I have 35 and I have 7 here. You can see that whatever thing what I'm passing to this particular change now is a copy of this my N1 variable, which is 7. I'm passing a copy to it, and after changing the value of 7 here by multiplying it by 5 and storing it inside this particular place, I'm returning I, right? It doesn't really change. It doesn't change the value of my N1. No, N1 remains the same, which is 7. It's only returning a copy of what it has created within this body of this loop. So when you are passing a value inside any function, don't think that you're actually cutting that value. No, you are copying that value and you are passing it as an argument into that function. And don't forget that whenever you are returning anything, you have to make sure that you are catching it somewhere. So I caught this my I now that I returned from that change function. I caught it inside this resource statement. I printed it out. Then I printed out my N1 to see if it has changed. It hasn't changed. It remains the same. So that's it about that. Then another beautiful concept that you need to understand about functions is this: whatever variable you create inside a function lives and die within that function. You cannot access a variable inside a function you created. You cannot access it outside that function. Let's give an example now. Let's assume okay, I have ROES here, right? Okay, I'm returning ROES. Okay, now I created ROES as a variable and I stored the sum of N1 and N2 within this place. Let me see if I used, okay, let us now access the value of ROES. Now I'm going to comment out everything here. I'm going to comment out this code here, and I'll come here now to do something like print ROES. Let me see if I can access ROES now. I'm going to run my code now and look at it. Yeah, it said process finished with exit code 0, meaning that there's an error. It said the name ROES is not defined. Exactly, it's not defined. This name ROES that you are seeing here, it's not within the scope of where I am using it. It is not a global variable. It is a local variable. It is only local to this particular function. It lives and dies within this function. It was created here, and immediately I returned a copy of it, it died. It died. So I'm not trying to access the ROES outside the body of this function. It's not going to work because it is not global in nature. It is only local to this particular function. It is not global in nature at all. So we're going to be looking at return types now. Now, whatever thing that you are returning from a function has to be the normal type, or whatever thing that you are passing to a function. It's not even that it must be numbers that you can pass. You can pass floats. You can pass whatever thing that you want to pass to a particular function. So whatever thing you are passing to a function must follow the normal data type. Is either a string or a boolean or a float or whatever thing that you want to pass. It has to be within the realm of those data types. Then multiple functions can be used within a function. Yeah, multiple function now can be used within a function and also within a file. Currently, we are on py functions.py, right? This is the name of the file. I've used about 2 functions here. I used the change and I used the add to. Yeah, you can write multiple functions within a function. You can define multiple functions within a file. I can define more functions. I defined 2 functions here before I commented out this code. I defined the change function, which is this, and I defined this other function here, add to. So you can define as many functions as you want. So a function can call other functions that are in the same file or are in external files whichever one. A function can call other functions that are within the same file or that are in an external file. By external files, I mean files that are outside the scope of this particular file now. This file now, I can create a new file now. Let's say I go here now, I create a new file and I call it my functions. Hit my enter key. Yeah. So from within this file, I can call this particular function. So it's not a must that all functions must lie within the same file. No, I can call other functions so long as the external files that contains definitions of other functions are connected to the file of the current function using the import statement alone or in combination with the from key. Now, Python has an import statement. Python has an import statement and a from key that you can use to import files into your source code. Let's say, for example, now I want to make use of this arg2, and this arg2 is currently defined within the PyFunctions Python file. If I want to make use of it in another file, now you have to use a special Python keyword called import. The import statement enables you to import external functions and classes that have been declared, that have been defined elsewhere in an external file. It enables you to import them like they exist within your local file. So if I use the import statement here now to import those functions from those files, it will seem as if I have defined it within this particular file. That is how the Python interpreter will see it to be. So I'm going to import these Py functions now into this my code. Now I'll say import Py underscore function is already there. Now when you are importing a particular file, please do not use the .py extension. No, it's not allowed. You have to just put only the file name there. So the fact that I have imported my Py functions now into this particular file is an indication that all the functions I have defined within these Py functions, they are now accessible to my to this particular file, my functions.py. They are now accessible to it. If I have two numbers here, let's say I have I equal to 17, I have J is equal to 9, and I want to add these two numbers. But the very simple fact that I have imported my Py functions into this file, I don't have to redefine an add function now within this file. No, I don't have to redefine it. I will just have to use the same function now that I have imported into this particular file. So I'll have to do something like Py underscore functions dot add. Is it add to? Yep. Then I'll now say I comma J. That's it. But have it in mind that it's returning something. I'll have to go back and do something like let's say results now is equal to this. So I'll come here now and print out result. Let's see if it works. Yeah, it's supposed to work. Yeah. It said name res is not defined. If process finished with exit code 0, meaning that it's not working. Based on the error I'm getting from here, the error is not actually coming from this particular function, from this particular file. It's coming from Py functions. I think it was my earlier code. I was trying to make reference to this. Yeah, this is where the error is coming from. So let me comment out this code and come back here and run my process finished with exit code 0. So it's run well. So let me see. Yeah, the result is 26. So that's it. So result is 26, 17 plus 9 exactly. So you can see that I never had to define this function again. I never had to define a function to add two numbers. I never had to do it. So it just came from this particular file I imported, Py function. But have it in mind that if you are using the import Py functions, the import command, it means that you have to write this particular guy, and you have to write this particular name, and at the same time write the function that you are trying to call. You cannot write only the function in itself. No, you cannot write only. It will get confused because it doesn't really know where you are coming from. So you have to write the name and the function name itself before using it. Now, I can decide to use the as keyword to abbreviate my function name. I can say import PyFunctions as PF. Then I will come here now to write PF. So whenever I'm using this is my pf.add, it shows that it is representing PF as this particular file name now, PyFunctions. So I have used another function from another file. Now, this is a very good practice. It enables you to modularize your code into different sections, so as you don't have to have one huge mammoth file where everything is being defined, declared, and called. Now, sometimes we might not, because this particular line that you are seeing here, yeah, it's cool, it's fine, it's okay, but the thing is that you are importing the entire functions that you defined inside this particular file. You are importing everything into this place, which is not bad, but a very good practice is for you to selectively import functions and import the functions that you know you want to use. So it's a better practice. So how do you do that now? Using Python. Now let me comment out this code, and I'll do something like from PyFunctions import add to. So that's it. Then when you selectively import your modules now, as in your functions, you don't have to use the file name anymore. You don't have to use the module name anymore. All you have to do is to come to this place, remove it, and it will work perfectly fine. Let's run the code again to see if it works. Yeah, it worked. 26. So when you are using this particular guy now, the from keyword, you don't have to import the entire functions now from that particular file. You have to indicate the exact function that exists within that same module. Let me uncomment this section of my code now, or rather, let me uncomment this part of my code that involves the change. Okay, now here's a change now, right? A change function, right? Okay. Let me do something like, if I have to use that change, I have to come here now to say from PyFunctions import change. So you are saying it is gray here because PyCharm is telling me that this particular function has not been used. It's just, I only imported it, it has not been used. So that's why it's kind of like gray here. But immediately I call this change function, it will change to this particular output. If I have to use it, I'll just go ahead to say change J, for example, now, and you can see that it has changed, and that's it. So you don't have to like import the whole thing. It's always good practice, like I said, to import only the things that you want to use. So let us write a function now that will enable us to like calculate someone's age in, say, let's say 8 years time now. In 8 years time now, how am I going to do that now? It's quite simple. I have to envelope everything inside a function. I have to package everything inside a function. I'll go ahead to say this is a quick one. I'll say define calculate future age. Okay, now a function name can never be too long. You can use whatever function name, whatever thing you want to use as a function name. Bottom line is that it should be descriptive in nature and be self-documenting. So I'll go ahead to say current age is equal to integer input. How old are you? Okay. Then I will go ahead to say print current age plus 8. So that's it. Now you can see that this particular function is a fruitless function. Are you getting it? It's a fruitless function because it's not returning anything. Like I earlier said, there's no emotion that a function must return something. Right now, you can rewrite this function so that it returns something. It all depends on what the nature of the program that you are writing, depending on the nature of the application that you are writing. If you are not going to be using the return value of this function, then there's no point returning anything. So I'm going to go ahead now to call this function. How do I call it now? Simply calculate function. Okay, it's already there. Now remember that because of the fact that there is no argument here, I never placed any argument here, so there's no point placing an argument. If I should place an argument there, it means that I'm violating the signature of the function. So I'm going to run this code. Now let me comment out this entire part of my code. Okay, and I will run this code here. And let's see how it goes. Okay, say how old are you? 12. And I'll hit 20. So meaning that in 8 years' time, this person will be 20 years. So our program worked correctly. The reason why you are saying 20 was because I used the print statement. If I never wanted to use the print statement, it means that I'll have to use the return statement. And if I use the return statement, I have to catch the result from here by storing it in a variable. Then I'll now have to print out that variable to actually get my results and see it. So that'll be all for today. Please don't forget to like, share, and subscribe. So catch everyone later. Bye.